So what are vectors and scalars? Well, vectors and scalars actually refer to quantities that have to do with magnitude and direction. Well, actually, vectors have to do with magnitude and direction, whereas scalars just has to do with magnitude. By magnitude, I mean the value. So I know that this is very vague, but hopefully after an example or two, I'll actually be able to explain this a little bit better to you. So let's get into that. So for example, a block has moved a distance of 5 meters. That's the only information that we're being given here is the magnitude. The magnitude is the idea that the block is being moved a distance of 5 meters, which is a scalar value. So if we were to say that the block has been displaced 5 meters to the right, well, that's a magnitude and a direction, which is indicating to us that we're dealing with a vector. So for vectors and scalars, we do have vector quantities and scalar quantities. Once again, vectors are having to deal with a magnitude and a direction, whereas scalars only have a magnitude, a value. So like in the previous example where we were saying that we were displacing a box 5 meters to the right, the displacement has both a magnitude and a direction, whereas for the scalar quantity, for the distance, we can actually say that we were able to move the box a distance of 5 meters. Notice that there's no direction there. So these are all of our vector quantities and our scalar quantities. If we were to actually be referring to velocity, I would have to say that we're moving at a rate or a velocity of 5 meters per second in a given direction. Now that direction could be north, south, east, west, up, down, left, right. It could be at a 45-degree angle. We have to specify the direction. Otherwise, we could actually just be referring to the speed. So you might be looking at these terms over here, and you might have an idea that velocity and speed relate to each other. Speed, on the other hand, just actually has to do with the magnitude and not direction. So 5 meters per second, hey, that's a speed. And a lot of the times through physics classes, as including this one, we might be actually just interchangeably using the terms velocity and speed, but really technically just know the idea that velocity is a vector and speed is a scalar. And we should really be saying in which direction it's going if we're referring to velocity and not having to specify that if we're dealing with a speed. Acceleration, we could say that an object's moving at 2 meters per second squared, and that's an acceleration, to the right, left, whatever the situation is. Forces, I could apply a 5 Newton force onto an object to the right. An increase and decrease in temperature, I want to actually decrease the temperature in my room right now. Time. Hey, you know what? Is there any direction in time? I'm reading my clock right now and it's 4 o'clock p.m. Is there any direction there? No. What about volume? I have a 20 milliliter bottle on my desk right now. Is there any direction in there? No, that wouldn't make sense. What about temperature? Hey, currently in my room right now, it's 74 degrees. Is there any direction in that? No. What about mass? 5 kilogram block. Well, there's no direction. It just wouldn't make sense that there would be direction there. What about density? In chemistry, you actually deal with density a lot, but the density of an object, hey, you know what? How dense is it? Well, that has nothing to do with direction. Same thing with energy. If I lift up an object, maybe you actually will remember this from 7th grade or 8th grade science. If I lift up an object, I'm giving it a certain amount of potential energy. The object just has energy. It doesn't have energy in any sort of specific direction. It just has it.